When you complete the program, today your participation will make you a white belt, and that is why I've mentioned here as white belt. But when you continue attending tomorrow as well as day after tomorrow, then you will transform into an yellow belt. So today itself, you will be learning all these things. Statistics for Six Sigma. Six Sigma is a data-driven approach. It makes use of the data. So understanding the basics of statistics is important. I am going to teach you that in the second section, right? And then I will take you a run through of the DMAC phases. Generally, a Six Sigma project, how it will happen, what are the activities, what are the steps, what are the tools and techniques. We will run through that. And in the day one itself, we will properly understand the meaning of Six Sigma. What is the statistical meaning of Six Sigma and what is the practical meaning of Six Sigma? What is the relevance of the Six Sigma in your field? You will gain absolute clarity, right? So the first item in our agenda is understanding the history behind Six Sigma, how it all started. So always knowing the history is important. Six Sigma evolved from a company called Motorola. You might have read it somewhere, right? Evolved from a company called Motorola. Let us go, even little earlier. Like after the World War II, the Japan was hit badly by nuclear bombs, and then the economy was down. The industries, they really do not know how to produce quality products, quality services, and they didn't had the principles and philosophies, whatever we are talking, and they were completely in a bad shape, Japan. So to help Japan recover the lost economy, and the Americans visited Japan and they taught them the basics philosophies and the basic principles about quality, and then continuous improvement philosophies, like people like Edward Deming, Joseph Geron, and Walter Shewart, and all of them visited and they helped Japan to know the fundamentals and quality practices. And as a result, what happened? The Japanese industry started improved. They improved their product quality and service quality, and the Japanese products have one time it become known for their quality. But what happened later on, somewhere around 1980s, the Japanese products and the services were become better than anyone else in the world. To that level, they have improved their quality standard. And it is around the 1980s. Motorola was also struggling to produce the quality products and services. Motorola is a US-based company. So in 1980s, Motorola was actually manufacturing. In 1980s, Motorola was actually manufacturing televisions in the brand name called Cuser. Televisions in the brand name called Cuser. But the problem which Motorola was experiencing is the television sets were failing after selling to the customer. Customers are purchasing your product, but after purchasing, the products are failing. Maybe after 2 months, after 4 months. Generally, the television sets comes with some warranty period, but the products were failing well within the warranty period. If the products are failing within the warranty period, what the customer will do? Customer will ask for the claims, isn't it? They will expect you to repair it free of cost, or they will expect you to replace the product and you are responsible for the failure. So Motorola was experiencing such failure. Such failures are called external failure. Why do I call it external failure? The customers are detecting the failure, not you, not yourself. You are the manufacturer, you produced it, but who is detecting the failure? Customer is detecting the failure. And why customer is detecting the failure? You failed to detect it before dispatching the product. Whenever you fail to detect a failure before dispatching the product, obviously that will lead to an external failure. Later, at a later point, customer will detect the failure and you have to pay a heavy price, isn't it? Imagine you manufacture windmill, and then you quality testing, everything is done, and then the windmill components are taken to the site and it is assembled, And after assembly, after 10 days, a problem happens. Now, is it easy for you to correct the problem? No, you have to again dismantle it, bring it back to the factory. Your cost of resolving the external failure will be 10 times, sometimes 100 times more than the internal failure. So it is always a wiser idea you to ensure you detect all the failures before dispatching the product. If you detect the failure before dispatching the product, the failure is considered only internal. The customer cannot know about it. You can fix it and then supply a defect-free product to your customer. So, but Motorola was experiencing an external failure and they were not able to, maintain or achieve a profitable business because of the external failure. So they were under heavy loss, and so they decided to sell the brand to a Japanese firm. A Japanese firm called Matsushita Electric acquired the acquired the Quasar. They took over the Quasar. You know what they did? They focused on the internal failure, which Motorola failed to focus. The Japanese firm focused mainly on reduction of the internal failure. What is the advantage if you focus on internal failure? External failure will disappear because you kept an eye on all the internal failure, and now external failures will disappear. So this philosophy worked very well with Matsushita Electric, and the same Quasar television have become very popular. And customers were happily buying it, and they made a lot of profit. And seeing the success of Quasar, see Quasar, and now Quasar is called Panasonic. Now Quasar is called Panasonic. And seeing the success of Quasar in the hands of the Japanese firm, the Motorola CEO, he understood one thing. He is the CEO of Motorola, Robert Bob Galvin. The problem is not only with the quality of the product, problem is also with our approach towards quality. We didn't know all these things, internal failure and external failure, and then we thought they were mostly reactive in nature. Instead of being proactive, they were reactive in nature, and that has led Motorola to sell the brand Quasar. So he wanted to have a 180-degree change, a drastic transformation in the way they approach towards the quality. Like how all of us are discussing today here in this meeting, he called all his executives. He called all the company executives and told them that they have to grow the company 10 times in the next 5 years. And the responsibility was given to Bill Smith, who is an engineer by profession, and another person, Dr. Michael Harry, who is a statistician by profession. So these two were the creator of Six Sigma. What is the responsibility given to them? To improve the company 10 times within the next 5 years in all aspects, right? Revenue, profit, customer base, market share, right? And share price, everything has to go up 10 times, and the responsibility was given. You know what they did? They developed a statistical approach. They developed a statistical approach, a metric-based system. Why statistics? Why metric? Consider the entire world now. Corona is spreading, lockdown is there everywhere. What every country is doing now? Every country, they maintain information about the spread rate of the corona and how the people are recovery rate, and even the death rate, and everything they started measuring, because the numbers can help you to understand how the situation is spreading, whether the corona has entered your country or not, whether the corona left the country or not. Can you see corona directly? No, but only with the numbers they understand. Same way, there are many aspects of your company's performance which you can't understand easily. With your visual eyes, you can't understand. You require data. Whenever you use data to understand how you are performing, your approach is called a statistical approach. This is what Bill Smith and Michael Harry developed. So they developed a statistical metric-based system. What is metric? A number that will tell you how are you performing. Sometimes you call it a metric, sometimes you call it a KPI. You call it a KPI. KPI means key performance indicator. This KPI will help you to understand whether your company is able to progress towards the attainment of goal or not. But metric will only tell you whether your performance is going on properly or not. That's the difference between KPI and metric. All KPIs are metrics, but all metrics are not KPIs, right? So they developed this statistical and metric based system, and as a result, they started understanding everything that is happening in the company, right? Everything that is happening in the company, this some metrics are developed, and looking at the numbers, they understood. And also, in order to resolve all the internal failure, they developed a problem solving methodology. They named the methodology, the problem solving methodology is a four-phase methodology. I'll tell about this gentleman, and he is Carl Friedrich Gauss. He is a German mathematician. He is the one who introduced theory of normal distribution. According to him, Carl Friedrich Gauss, any natural event in this world happens in a particular way only. And if you collect the data and visualize it, it will appear like a bell shape. And he called the pattern as normal distribution. If you understand the normal distribution, you can understand everything that is happening in your company just by using the data. If you don't have the knowledge about the normal distribution, then you can't work with the data. And so the knowledge on normal distribution is used by Bill Smith and Michael Harry, and to solve all the problem, they developed a methodology called MAC, M-A-I-C. M means measure, A is analyze, I is improve, C is control. What gets measured gets improved, right? So they developed this methodology using which they solved all the internal failure. It worked very well for Motorola, and over a period of 10 years, they have almost solved all the problems, and then they made the organization completely problem-free. As a result, they started producing quality products, and that has helped Motorola make a saving of $16 billion exclusively through Six Sigma projects. And that's not a small money, $16 billion those days, even today. And Motorola was awarded Malcolm Baldrige and National Quality Award in the year 1988. And today Bill Smith is known as father of Six Sigma. And Dr. Michael Harry and team, they developed the belt levels. Because for somebody to participate in a methodology developed by them, MAC methodology, so he has to be trained, isn't it? Without knowing, if you expect people to work on it, and they can't work effectively, and then they can't produce the result. So he developed belt level, and according each and every belt level will speak about a specific amount of knowledge and ability to participate in the Six Sigma project. So belt levels like white belt, yellow belt, green belt, black belt, master black belt. These levels are created, and thereby whoever participate in the project, he will be able to actually contribute to the success of the project. And they named this methodology as Six Sigma. And why it is Six Sigma? We all studied Sigma means standard deviation in 7th standard schooling itself. Sigma means standard deviation. And according to normal distribution, if you center your process, or if you operate your process at a distance of 6 sigma units from the customer specified limit, where is your process operating? At a distance of 6 sigma. When you operate your process that manner, your process will start producing defect-free output. You may find it difficult to understand this particular statement. You are operating the process at a point which is at a distance of 6 sigma units from the customer specified limit. When you make it, when you operate it like that, your process will start producing defect-free products or defect-free output, and that methodology is called Six Sigma methodology. So this is why we call the methodology MAC as Six Sigma methodology, right? And at that point, the failures will be limited only to 3.4 DPMO. Failures will be limited to only 3.4 DPMO. What is DPMO? Defects per million opportunities. If you produce 1 million outputs, how many defects can happen? Only 3.4 defects can happen. When that will happen? When you operate your process at a distance of 6 sigma from the customer specified limit. You will understand this statement probably after 2 to 3 hours from now. If you right now, if you understand, then definitely you are in a great position right now. And one more thing happened. So Six Sigma evolved from Motorola, but later many other companies adopted it. Many companies adopted it, and one such company is General Electric. And General Electric was headed by Jack Welch that time. The CEO of General Electric was Jack Welch. So Jack Welch and team, they converted, sorry. So I'm sorry. So Jack Welch and team converted the methodology MAC to DMAC because Motorola thought that what gets measured gets improved. But Jack Welch thought defining the problem is more important before measuring. So he added D in front of MAC, and MAC has become DMAC. MAC was four step, DMAC was 5-step methodology or 5-phase methodology. That happened in 1995. That happened in 1995. And then onwards, the Six Sigma methodology is always 5-phase methodology only, DMAC methodology only. Near about 26 years, it helped many industries. Almost it is today applicable in every industry in the world, and it is applicable in your industry also. If you learn and then practice the DMAC methodology in your department, in your company, you will also be able to produce magical results. And later, around 2000, Six Sigma and Lean got integrated. So what is the focus of Six Sigma? Focus of Six Sigma is producing defect-free products. How it produces defective products? By proactively arresting or proactively reducing the internal failures, right? So Six Sigma is a defect prevention technique. And what is the role of Lean? Lean will make you produce defect-free products faster. See, the Six Sigma's goal is produce defect-free products. The goal of Lean is make you produce defect-free products faster. So the Lean will focus on eliminating the wasteful activities. Lean will focus on eliminating wasteful activities. If you eliminate the wasteful activities, you will be able to execute the work faster. As a result, you will not only produce quality products, you will also produce quality products faster. And that is the reason why Lean and Six Sigma are integrated. So this is what we are going to learn from this training program. Any questions here in this slide?